So this video lesson is looking at pulley problems. So you should have looked at the slide deck that has all of these practice problems in it, and you need to copy slide number 1 from the slide deck, which is just the important information to know about a pulley problem. And so with all of our pulley problems, we are going to have a pulley with some rope or string, and we're going to have two objects attached to our pulley. And in our class, we are going to assume that our pulley is frictionless and that our pulley has no mass. We are not assuming that the surface of our blocks are frictionless, but we are going to assume that we are using a frictionless pulley and a pulley that has zero or negligible mass. Okay, so we are going to start with practice problem number 1. So practice problem number 1, we have a block of wood sitting on a table. So we're going to draw ourselves our diagram. So we have this block of wood on the table, and it is 4 kilograms. And it's attached to a pulley. And we've got a rope. And we have a mass that is hanging down. And that mass is 1.8 kilograms. Okay. We are also told that we have a coefficient of static friction, but we don't actually know what the coefficient of static friction is. So that is what we are trying to calculate in this problem. So looking at this pulley, one of the first things we always do in a forces problem is draw a free body diagram. And so I'm just going to do a little bit of labeling here. So I'm going to say that this is going to be object number 1 for me, and this is going to be object number 2. Now the reason for that is because I need to draw a free body diagram for each of these objects, and I want to be able to tell the free body diagrams apart. The other thing I want to do is I want to label the motion on my pulley. So even though this pulley is not moving, if it were to move, I'm going to assume that it's going to move down like this. You can assume that it's moving up if you want to, but that is really, really rare. And worst case scenario, if we get the motion direction wrong, we're just going to get a negative answer. And so then we just turn the motion direction around. So we're going to assume that our pulley is moving to the right and then down. Okay, so we're going to draw our free body diagram. So for block number 1, our free body diagram, we're going to have a force of gravity pulling down block number 1, so I'm going to call that FG1. We're going to have a normal force because block number 1 is sitting on a table. We are going to have a static friction force, so that's going to be FS, that is pulling the block backwards from the motion. And we are going to have a tension force because of the rope that is attached to our block. And so that one's going to be our block number 1. And in block number 1, our motion is going along the x-axis, and tension is the positive direction. Our static friction force is going to be the negative direction. With block number 2, we have fewer forces acting on it, but we still have an FG, so we're going to call this one FG2, and we still have a tension force that's pulling it upwards. Now, I labeled our tension forces exactly the same because this rope is the same rope, which means the tension that's in the rope is the same no matter which object it's attached to. So they are actually the same force. And so we've got our T there. Now, with our second block, our motion is actually down. So our motion is going down. The block is moving downwards if it's moving at all. And so we're labeling our motion in there as well. All right. Now, tricky thing with pulleys is that even though our motion is actually changing direction, because our motion goes on the x-axis of block number 1 that's on the table, and then it continues onto the y-axis of block number 2, we are going to actually, those are all happening on the same axes. They are a continuation of each other. And so we can actually do our net force on what we would call that x-axis. Okay, so we're going to have our F net x. Okay, and so we are going to add in our x forces, so the forces on the x-axis for block number 1, and the forces on technically the y-axis for block number 2, but we're saying that the y-axis of block number 2 is just a continuation of the x-axis for block number 1. So our F net x is going to be a negative Fs, because that's going opposite our motion, a positive tension, and that's the tension that's coming from block number 1, free body diagram. We're going to have a negative tension that's coming from block number 2's free body diagram, because it's going opposite our motion. And we're going to have a positive Fg2 coming from, again, block number 2. And so that means that our F net x is going to work out to be our Fg2 minus our Fs. Okay, so we're going to have Fg2 minus Fs will be our F net x. Now, since we knew that this was not moving, we also know that F net x is going to be 0. So we can set that equal to 0. So 0 is equal to our Fg2 minus our Fs. And this is the equation that we're going to use to solve for our coefficient of static friction. So we're going to rearrange a little bit. So I can rearrange, just to show that my Fg2 will actually end up being equal to my Fs. And I'm going to substitute some formulas in here. So Fg2 I know is really the mass of block 2 times g. And Fs, I know the formula is really mu s Fn. And I'm going to keep doing a little bit of substitution here, because I also know that Fn for block number 1 is going to be the Fg for block number 1. So this is for block number 1. And so I can substitute Fg1 here. Okay. So then I can continue to substitute, because my Fg1 is actually m1 times g, because the Fg formula is always mg depending on the mass that you're looking at. So now I have everything in this equation except for my mu s, so I can just rearrange to solve for mu s. So my mu s is actually going to be my m2g divided by my m1g, and so that's nice, g will just cancel out for us. And so mu s will actually be just m2 divided by m1. And so our mass 2 was 1.8 kilograms. And our mass of block number 1 was 4 kilograms. And so then we're just going to do our math there. So we've got our final answer of mu s is 0.45. Don't forget, mu s has no units, okay? And we've got 2 significant figures because that's what we were given in the question. So we've got our mu s, that's practice problem number 1. Okay, so we're going to move on to practice question number 2. Okay, so again, these practice questions are coming from the slide deck that you should have copied out slide number 1, but then I'm just giving you the practice questions in the slide deck. So this is practice question number 2. Okay, so in this one, again, we've got a pulley with a block on the table. So it looks very similar. You'll notice that pulley problems actually all tend to look very similar to each other. And we've got a hanging block. Only this time our block on the table is 3.2 kilograms. Our hanging block is 1.5 kilograms. We are given a coefficient of kinetic friction as 0.30, and so this is for block on the table. And we are looking to find a couple of different things in this question. So we are first going to try and find the acceleration, then we are asked to find the tension, and then we are going to do a little bit of kinematics. So how far will the objects move, given initial velocity, and a time. Okay, so we are going to start with acceleration. So the first thing we always want to do, again, right, we're going to mark our motion. Okay, and I'm going to say again that my block on the table is going to be block number 1. My hanging block is going to be block number 2, so that I can keep them straight when I am drawing free body diagrams. So free body diagram for block number 1, we're going to have our FG1 pulling it down, FN going straight up, we'll have our FK, and then we'll have our tension. And in this we've got our motion on the x-axis, okay? With block number 2, we're going to have an FG2 pulling it down and our tension pulling it up. And then we're going to have our motion pulling block number 2 down. So we're going in that downward motion. All right, so again, here we're looking at our F net X, but again, we're using the X-axis for block number 1 that's on the table, and we're going to use the Y-axis for block number 2 because we're going to follow that rope all the way through. So again, we're looking for F net X, and in this case, we're going to have our negative Fk plus our positive tension for block number 1 minus our tension for block number 2. It's going opposite our motion plus our FG2. So we're going to end up with an F net X that is FG2 minus Fk because our tensions are going to cancel each other out. All right, in this case though, our F net X is going to be MA. We're told that our block system is moving a little bit because we have a mu K, which means we have kinetic friction, which means we're moving. And so we are going to have to substitute MA in for our F net X. So we're going to have MA is equal to our FG2 minus our Fk. Now, a couple of small things here. So in this side of the equation, the MA, that has to be the mass of block 1 and 2. Whereas if we have an FG, that FG is going to be the mass of just the object that it's for. Okay, so I'm going to rewrite this equation here, only I'm going to label it a little bit better. So this is really the mass of m1 plus 2 times my acceleration. And then FG2, we know we can substitute and say that's really m2g. Fk, we know we can substitute mu k Fn, and then we can keep substituting till we get to a point where we have the things to plug into our equation. So we have m of 1 plus 2 times our acceleration will be m2g. Okay, for Fn, we can substitute Fg1, and then we can keep substituting. So Fg1 will be m1g. Okay, and so now we get to a point where we have all of these things. And so we're just going to do one more substitution so that we can solve for acceleration. So acceleration is going to be my m2g minus my mu k m1g divided by my m of 1 plus 2. Okay, so my m2g was 1.5 kilograms. G was 9.8. Just a reminder, mass has to go in kilograms. So if you ever have masses in grams, make sure you convert to kilograms. Our mu k was 0.3. Our mass of 1 was 3.2. G is always 9.8. And then our masses on the bottom here, we're going to have to add them together. So we have our 1.5 mass plus our 3.2 mass. So then we're just going to plug that into our calculators. And we're going to get an acceleration of 1.1 meters per second squared. And so that's going to be our acceleration. That's part A of this question. Oh, acceleration is part A. Another reminder here, don't forget when you're plugging in your numbers here to make sure that you're following bed mass rules. So you're doing multiplication, etc. before you do addition or subtraction. All right, so we've got our acceleration here. Oh, and we need our direction. It's going down. We decided that at the beginning of the problem. Okay, so then for part B, we are going to try and find the tension of the string. Now for part B, we are going to actually look at just one of the objects. So when we look at the entire system, remember if we go all the way back to our formula here, our tensions canceled each other out because we had tension acting on block 1 and tension acting on block 2. So if we want to find the tension, we can't look at the whole system at once because the tensions will just cancel each other out. So we need to instead look at just one object. It is much easier to look at object 2 because it has far fewer forces. So we're looking at only block 2 to solve for our tension. So when we are looking at block 2, the net force for block 2 is our FG2 is heading in the positive direction, and our tension is heading in the negative direction. And so we're going to substitute our net force acting on block 2 for our mass times our acceleration. Only here, this mass is only block 2. We decided at the beginning of this we were looking at just block 2 to find the tension, and so we have to continue to look at just the mass of block 2. But our acceleration is going to be the same acceleration because we already determined how the block is accelerating, and its acceleration doesn't change when we look at them individually or whether we look at it as a system. So then we're just going to rearrange this to solve for T. So we're going to end up with our tension is going to be our M2G minus our M2A. And so mass 2 was 1.5. So do 1.5 times 9.8. And then again, 1.5 over here. And then we're going to use our acceleration that we solved for in part A. And we're just going to plug this into our calculator. So we're going to get a tension of 13 newtons. And you can use block 1 to find the tension. You should get the same answer if you're using block number 1. But I find block number 2 much easier to find the tension since there are fewer forces acting on block number 2. All right, so then for part C, we want to know how far our objects are going to move in 1.2 seconds. So we're given 1.2 seconds as our time. And we're given an initial velocity. So our initial velocity is 1.3 meters per second to the right. And we also know our acceleration. And so we are going to look for how far the objects are going to move. So we're going to look for delta D. And so we're just going to use a kinematic equation for this. So we have time, we have VI, and we have acceleration. We're looking for displacement. So I think we're going to use that kinematic equation. Delta D is equal to VI delta T plus 1/2 A delta T squared. So we're just going to sub into our kinematic equation here. So we've got our 1.3 meters per second. We're going 1.2 seconds. Our acceleration is 1.1. And so then we're just going to plug that into our calculator. And we got a displacement of 2.3 meters. My pen doesn't want to work right. So we got our displacement of 2.3 meters. So we're going to go 2.3 meters. The practice problem has an answer in the slide deck. It says 2.4. That's because it was 2.35. And so you could round up or round down for your significant figures. So a delta D of 2.4 would have been acceptable as well, right? Because we ended up with 2.35. And with a 5, you could round up or round down. Okay, so that's practice problem number 2. So let's move on to do practice problem number 3. And so practice problem number 3 looks a little bit different. It can look a little scary, but I actually promise you it's actually easier when our pulley system looks like this. So again, we have a pulley system with 2 blocks, only this time the blocks are hanging like this. Okay, so our blocks are actually both hanging on either side of the pulley. And so here we're given that block number 1 is 2.5 kilograms, and block number 2 is 1.9 kilograms. We're looking for a free body diagram. We are trying to find the acceleration and the tension. So this is practice number 3. Okay, and so one of the first things that we want to do is we want to determine which direction our motion is going to be in. Since block number 1 has a larger mass, I would assume that it's going to move down and block number 2 is going to get pulled up. So I'm going to assume motion going in this direction. If you pick the wrong direction, not a big deal. You're just going to get a negative acceleration as your answer. That's it. So I would always pick the direction with the largest mass, but it's up to you. Okay, so we are going to draw our free body diagram. So block number 1 has FG1 acting down on it, tension acting up. Block number 2 has FG2 acting down, tension acting up. So these problems actually don't have normal forces, nor do they have friction forces, since we are assuming that our pulleys are frictionless and there's no friction from the rope, etc. So they actually end up being quite a bit easier. Now, in terms of our motion though, okay, so for block number 1, our motion is going down. For block number 2, our motion is going up. Okay, and so because we're following the motion of our tension. Again, here it's the same string, which is why our tensions are not like T1 and T2, because the tensions are the same since they are the same rope. Okay, so in this problem, we are going to look again for our F net. Okay, and so our F net in this case, we are going to have an FG1 going in the positive direction. We have our tension going negative, right? Negative direction for block number 1. But then we have a positive tension from block number 2. And then block number 2 would be negative FG2. So we're going to end up overall here with an F net. Hold on, my pen is acting funny. So we're going to end up with an F net of FG1 minus FG2. Okay, since we are looking for acceleration, we can assume that our net force is, we're using Newton's second law, so we're using the mass times the acceleration. So we're going to have MA is equal to our FG1 minus our FG2. Okay, again here, this mass in our net force, that is going to be block 1 and 2. Okay, so we should denote that in our next line. So that's going to be the mass of M1 plus M2. And so that's going to be A. And then FG1 we know is just M1G. And FG2 we know is M2G. And so then we can just rearrange to solve for our acceleration. So our acceleration is going to be M1G minus M2G divided by the mass of M1 plus 2. So we're going to sub in our values here. So our M1 was 2.5 kilograms. G is 9.8. And M2 was 1.9. Again, G is 9.8. Then we're going to divide by our masses added together, 2.5 plus 1.9. So then we're just going to plug that into our calculator. And we get an acceleration of 1.3 meters per second squared. So that's our acceleration. Okay, now we are looking for the tension. And again, just like we did with practice problem number 2, in order to find the tension, we're just going to choose one of our blocks to have a look at. So let's focus on block number 1 here. Doesn't matter which block you use. So we're looking at only block number 1 to find our tension. So if we look at only block number 1, our F net is going to be our FG1 minus our tension. Okay, so we're only looking at the forces acting on block number 1. And again, our F net is going to be M times A, only this time it's going to be just the mass of block number 1. And then we know that Fg will be M1G. And then we've got our tension in here. So then we're going to rearrange to solve for our tension. So tension is going to be our M1G minus our M1A. So then we're just going to sub in our values here. Block number 1 again was 2.5 kilograms. And our acceleration, we calculated already, was 1.3. And so we got a tension of 21 newtons. And so that's our final answer for tension. So we've got our 21 newtons. All right. So now you have practice problem or practice questions number 4, 5, and 6 that you can try on your own. And you can have a look at the answer key, but try to do the questions on your own first before you look at the answer key.